Welcome to the fascinating world of space oddities. Today, we're diving into the mystery of Phaethon, a peculiar asteroid that behaves like a comet. But what's the real difference between these two celestial bodies? Comets are essentially dirty snowballs, chunks of rock and ice that when they approach the sun, release gases and dust, forming a glowing tail that we often see streaking across the night sky. Eventually, comets either burn out or break apart, leaving behind only rocks or dust. Asteroids, on the other hand, are mostly just rocky bodies that quietly orbit the sun, far from the dramatic tails and bursts of comets. But here's the twist. Phaethon blurs the lines between these two space objects, earning it the nickname Rock Comet. And it's more intriguing than you might think. Discovered in 1983 by astronomers Simon Green and John Davies, Phaethon was initially spotted during an analysis of images from the infrared astronomical satellite, IRAS. Soon after, astronomers realized that Phaethon is the source of the annual Geminid meteor shower, one of the brightest and most reliable meteor displays we see each December. As Earth passes through the dusty trail left behind by Phaethon, we're treated to a dazzling light show. But here's the real puzzle. Unlike typical comets, which shed dust and gas as they near the sun, Phaethon isn't currently releasing enough dust to explain the Geminids. Even more perplexing, Phaethon's orbit brings it incredibly close to the sun, closer even than Mercury. At its closest approach, or perihelion, Phaethon's surface heats up to a scorching 730 degrees Celsius. You'd think such intense heat would either strip away its surface, causing it to shed material like a comet, or create a protective crust that prevents any more dust or gas from escaping. But neither of these scenarios seems to be happening. Instead, Phaethon continues to emit gas like a comet, but without the expected dust cloud. So, what's going on beneath its surface? This is what the scientists set out to understand. In a recent study, published in Nature Communications, a team led by Martin D. Suttle simulated the intense solar heating Phaethon experiences using meteorite samples, similar in composition to the asteroid. By repeatedly heating these samples in conditions that mimic Phaethon's environment, the team found something surprising. Small amounts of sulfurous gases were released slowly over many heating cycles, rather than all at once. This suggests that even after numerous close encounters with the sun, Phaethon still has enough gas trapped beneath its surface to create comet-like activity. But how does this work? We believe that as Phaethon heats up, iron sulfide minerals in its subsurface break down, releasing gases like sulfur dioxide. However, because Phaethon's surface isn't very permeable, these gases can't escape easily. Instead, they accumulate in cracks and pores beneath the surface. When Phaethon rotates, completing a spin every 4 hours, its subsurface cools, causing some gases to react and form new compounds. When the sun heats Phaethon again, these compounds break down, releasing more gas and repeating the cycle. This discovery is more than just a scientific curiosity. It has major implications for the upcoming Destiny mission by the Japanese space agency JAXA, which is set to study Phaethon up close. The mission will use advanced instruments to analyze the dust and gases around Phaethon, potentially validating our theory. If proven correct, our findings could change how scientists think about solar heating, not just for comets, but for asteroids as well. And Phaethon isn't alone. Around 95 other asteroids come within 0.20 astronomical units of the Sun, and what we learn from Phaethon could help us understand these objects too. Finally, what about the Geminid meteor shower? The most likely explanation is that Phaethon shed dust long ago, creating a debris trail that Earth now passes through each December. So, as you watch the Geminids light up the night sky, remember that you're witnessing the legacy of an asteroid-comet hybrid that continues to baffle and inspire us. Stay tuned for more updates on this cosmic mystery. As we conclude this virtual odyssey, we invite you to like and subscribe to our channel to embark on further cosmic explorations. With every click, you elevate our pursuit of knowledge and contribute to the collective understanding of our universe.